Hello and welcome to the EMC Live webinar, Compliance for Kickstarters, Selling Your Innovation Around the World. My name is Belinda Stashikevich and I'm editor of Interference Technology, the creator of EMC Live. EMC Live Design Bootcamp is a new online one-day event hosted by Interference Technology. Featuring practical information and topics, this event will include roundtables, webinars, and everything EMC design related. There's no cost to attend. Attend our roundtable a little later on wireless at 1:30 p.m. Eastern Time, and our webinar on simulators for SIPI and EMC a little bit after that. Our test bootcamp will take place November 12th. Our three-day event will take place April 23rd to 30th. If you want to ask questions today, you can go on Twitter and use the Twitter hashtag EMCLive. This webinar is presented by Mike Violette, President of Washington Laboratories, and Steve Koster, Vice President of Washington Laboratories. Mike has 25 years of experience in FCC, CE, IC testing and certification, is a professional engineer and an INARTE certified EMC engineer. He's currently on the board of directors of ACIL. He's a notified body for Radio and Telecommunications Terminal Equipment Directive and the EMC Directive. Steve has dealt with EMC and radio requirements for the last 21 years. He has tested or directly supervised thousands of projects over the years and presented at the EMC Symposium numerous times discussing test setups for FCC testing. This webinar will be interactive. You'll be able to ask questions and answer polls. We encourage you to participate. Take a look at your GoToWebinar navigation pane, the box on the right-hand corner of your screen. If at any time you have a question, we ask you to fill up the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand, to ask a question or report an issue, click the hand icon. We'll present the topic for 35 minutes, followed by a 10-minute question and answer session. Now Mike and Steve will begin the presentation.
Good afternoon, everybody. This is Mike Violette, and welcome to this Design Bootcamp. Belinda, thank you for the opportunity to present today. Today we're going to talk about compliance for Kickstarters. That's what we're terming this. And we're going to spend about 45 minutes going over some of the general requirements that may apply to products being launched in the technology space. Briefly, Washington Laboratories is an EMC product safety and radio frequency test laboratory located near Washington, D.C. We do a variety of work with commercial, consumer, defense, aerospace, energy, and quite a bit in the wireless space. We've been doing this since 1989, and we work across the spectrum from industrial controls to nuclear power stations, energy, and telecommunications, and we are a partner laboratory with TUV Rhineland. American Certification Body, our sister company, has operations overseas in Europe and in Beijing, China, and Taiwan. And we work across this wireless spectrum and perform about 1,400 certifications every year. Belinda's already introduced us. Here's an overview of our presentation. What we'll do is through 4 different general topic areas. I'll talk a little bit about some of the background, then I'll turn it over to Steve, who will do a regulatory overview of the U.S. and Canadian regulatory structure. And then I'll join in and do some discussions about international requirements that you may consider when you want to launch your device overseas. So some background on the Kickstarter phenomenon. This is a huge area that people are getting more and more comfortable with in crowdsourcing products and projects to everything from postcards to rock and roll. In 2013, about $380 million was pledged, and the total that has been raised through this particular crowdsourcing phenomenon platform is about $1 billion. And looking at some statistics, there are approximately 8 million backers across the whole international 200 countries and territories. And of course, depending on the way the Kickstarter thing is arranged, you have rewards depending on the amount and how early you join in the crowdsourcing activity. So this particular phenomena has led to some interesting projects. There was one project where a gentleman wanted to develop a human-powered helicopter, and $34,000 was pledged to that. This other gentleman made a DeLorean hovercraft that cruised the San Francisco Bay, and $5,600 was pledged to achieve that dream. And on the technology space, there's been innovators that have been funded to the tune of $1 million pledged for a 3D printer with 2,000 backers. And the largest one that I could find on the Kickstarter website was almost $9 million pledged was for a video streaming device, which is a phenomenon. So what we look at when we look at some of these things, and the reason why we decided to come up with this compliance for Kickstarters, that we're starting to get questions from some of these innovators on how to make their products developed for international regulatory requirements. One particular IT device in our state of Maryland here, there was $3 million pledged for a 3D printer, and it started looking at where these pledges came from. Of course, not surprising, the largest concentration came from the U.S., but you can see the spectrum of countries that have been pledged, up to 84 countries for this particular device. So as part of the rewards package that this company had pledged, they had to get regulatory approvals in a lot of these countries so they could legally sell these devices to these 84 different countries. So this kind of was the impetus for putting together this presentation. So when people develop these innovations, they may not always be thinking about what some of the compliance issues are. What could possibly go wrong? Well, we have to think about electrical safety. We have to think about mechanical safety. We have to look at biologics if you're handling chemistry or if you're handling a food product. Obviously, if you have a wireless device, you have to think about the radio spectrum and EMC considerations. And if you're selling the things in some jurisdictions, you have to be very careful about material selection because there are some banned toxic products or chemicals and materials and some that can be used. So in the end, you have to look at approvals, and this is what we're going to talk about a little bit today. Some of the devices I looked at had some inherent risks involved. This particular device on the left was a routing machine, and obviously there's mechanical safety. And the device on the right has some intrinsic safety concerns because it controls a cutoff saw. Other devices incorporate laser type of products, and if you're doing an engraving type function, you obviously may have some high output levels. You have to think about laser safety. So when we look at compliance definitions across the spectrum, we look at a couple of different terms. So I'll define these things quickly. EMC, Electromagnetic Compatibility, is one aspect where you don't want to have devices interfere with other devices in the area, and you want to maintain proper operation in its environment. The spectrum issues applies to wireless transmitters. Product safety is a concern from electrical, mechanical, fire, and chemical hazards. And on the environmental side, you may have restriction on hazardous substances, or you need to concern yourself with disposal at the end of the life of the device. There's also a related directive, particularly in Europe, called the REACH directive, which is principally for raw materials and listing and registration of those materials in the European Union. There may be other things that you may consider if you're, say, developing a toy. You have toy safety issues. And if you're developing a device that may go in, say, petroleum handling facilities or grain processing facilities or anything that may have explosive atmospheres, you may have to consider explosive atmosphere certification. And if you're developing a device that may contain high pressure, you have to consider pressure vessel requirements. And of course, there's a large spectrum of requirements for automotive industry. So on the safety side, we're concerned with several different types of safety. Number one, mechanical safety. Two, electrical safety against shock and burn type of hazards. And if you're dealing with a radio frequency device, you may have to concern yourself with the radiation hazards to human tissue. And this is broadly defined as SAR, specific absorption rate, or maximum permissible exposure requirements. And these requirements apply to many different types of wireless transmitters. And as I mentioned before, if you have a laser device, you may have to concern yourself with the laser safety to protect the human sight. So in this particular area, you have different definitions of compliance. And one particular term that's used quite a bit is so-called declaration of conformity, which essentially is a manufacturer's self-certification that they meet the requirements. You also may have third-party certification. This is typically delivered through an independent laboratory and may include, for international requirements, something called the Certification Body Scheme, or CB scheme. At the top of the sort of hierarchy of these things is accreditation, which applies to the third-party certifiers. And there are international agreements that allow accreditation to be accepted across different platforms, across different economies. So in the end, you end up with something like this, and this is a common power supply that I had on my desk, and you can see all the various different certification marks. Now, what is common, there's a lot of commonality in the technical requirements here in terms of performance, safety, in terms of electromagnetic compatibility requirements, but each individual region or nation may have separate requirements. In North America, the EMC requirements are regulated by the FCC in the United States and Industry Canada. Safety is principally under the auspices of the National Electrical Code, and for workplace safety, the Occupational Safety and Health Administration. And a lot of these particular things are managed on a provincial basis, particularly in Canada. In Mexico, you have the NOM directives, which is the Mexican norms. Medical devices may be regulated by the FDA under their 510K program, and they look at not just safety but also efficacy of the device. For laser devices, the FDA also regulates these under the Center for Devices and Radiological Health. In Europe, briefly, the regulations flow through what's called directives, and there's several different directives that apply across different scopes and across many different types of products. We have the EMC directive, the low voltage directive, medical device, machinery, and the radio and terminal equipment directive, which is going to evolve into a radio equipment directive. I'll speak briefly on that a little bit. For Europe, self-declaration is allowed for many types of products as long as you meet the essential requirements. A notified body, which is an authority that has been essentially accepted in the nation where they operate to render opinions, may be required for certain classes of equipment, notably some medical and some very dangerous equipment such as chainsaws and other highly hazardous equipment. In that case, you may need a notified body opinion. This is a list of all the European directives, or many of the European directives. And you can see that it spans the spectrum from safety, low voltage, to construction products, machinery, personal protective equipment such as goggles, glasses, and gloves, medical devices. And broadly for EMC, electrical and electronic equipment are covered under this particular definition. European requirements also have broadly based environmental directives. I mentioned these before, which is RoHS, the Restriction on Hazardous Substances, and this has limits, specific hard limits on how much these kinds of hazardous metals and materials may end up eventually in landfills. So these different things are banned to a certain level: lead, mercury, cadmium, hexavalent chromium, and these other polybrominated biphenyls and ethers. So those requirements are on a product basis, and your product must meet these limits. In a lot of cases, this is self-declaration for this type of compliance, and often it's a supply chain issue. And you need to make sure that your suppliers are attesting that the parts that you're sending, that you are integrating from them, have met these limits. Aside from Europe, there's other markets, obviously, and this is country-by-country specific regimens, and you need to understand what those regimens may hold. In some cases, some countries do regulate, for example, the radio spectrum. Sometimes they lightly regulate it or may accept, say, either European compliance or they may accept North American compliance. Many countries do regulate product safety to a degree, and I mentioned the CB scheme as a potential route. And what this allows you to do is to test once for the broad base of requirements at a CB authorized laboratory, and then you can bring that report to other countries, and depending on the country you may have to do some additional retesting. So strategies for compliance. Well, the broad-based. You should refer to international standards when you're developing your product, when you're selecting methods, and when you're selecting parts. You need to determine your target market. And you may use, in these target markets may accept international or IEC standards. And broadly, you should always source components that already have been approved. And so this is kind of the alligator in the pond. And when you're specifying things like connectors, power supplies, mains devices, anything that may be connected to hazardous voltage, it's critical that part of the approval process is to check the certifications on those devices, on those parts. So I'm going to turn it over to Steve Koster, who's going to run through the U.S. and Canadian regulatory structure. Steve?
Thank you, Mike. The United States, the regulations are all written in the Code of Federal Regulations, Title number 47 for electronic equipment. Part 2 has the general requirements. Part 15 is on licensed requirements. Parts 22 and 24 for licensed cellular devices. Part 87 and 90 for licensed marine and land mobile devices. As you see, it covers pretty much all of the transmitters that we do. SAR is ANSI 95.1 is, as Mike indicated, is specific absorption rate, and it deals with RF hazards. Industry Canada has a whole set of their requirements, ICE 03, unintentional radiators and digital apparatus. The RSS Gen is generally an overall document. The RSS 119 is for licensed land mobile devices, and the RSS 210 is for unlicensed short-range, low-power devices that we do for unlicensed, that we are similar to unlicensed devices in the United States. Most of the technical requirements are harmonized with the FCC, so a lot of times you can do the test once and show compliance for both countries. There's two main areas for the EMC. There's the conducted and radiated emissions. What is your device putting out over the air or over the power lines or conducted down the cables? And there's conducted and radiated immunity. Typically for Europe, you have to be able to operate in different environments that could be hazardous or could cause issues with your device. Also, when you're working with different things, you've got network connection protocols, CTIA or PTCRP, usually by carrier, and they have to be done before you can connect to those carriers. The FCC has the authority over the radio spectrum since 1934. To make available a rapid, efficient, nationwide and worldwide wire and radio communication service for the purpose of national defense. So the FCC is responsible for the integrity of the airwaves, the use of the spectrum, the licensing and operation of RF systems, certification, and under that they have a database of thousands of products, and they have frequency, power limitations on use, and responsible party information in that database, and they're responsible for RF safety as well. There's different types of authorizations. There's a verification. That's the least interfering equipment, Class A digital devices, radio receivers. These are devices that you would find in a office environment or things similar to that. There's the declaration of conformity or Class B digital devices, computers and peripherals. They're in the homes. They have a higher possibility of interfering with different things. And you have certification, the international intentional transmitters, both licensed and unlicensed. They have to be certified. Now, Industry Canada has pretty much a similar technical limits and rules. They verify digital devices, and they also do certification for radio transmitters. FCC had, in 2000, had 4,011 devices certified that year. Now the FCC in 2013 had 17,000 devices certified. You can see there's an explosion in wireless devices. And they go from power levels from milliwatts to hundreds of watts, depending upon the device. Unlicensed low power is proliferating. Probably every person out there has 3 or 4 different unlicensed transmitters in their pocket at this time. Phones, key fobs, things like that. Broadband technologies are expanding. We're trying to get more and more information, and that uses wider bandwidth. Frequency allocations are changing and expanding. We're pushing up into the gigahertz. We're reallocating spectrum in the United States, things of that nature. And in order to help the FCC, they started the TCB program in the year 2000. TCB stands for Telecommunication Certification Body. And then Canada started their program shortly thereafter, basically privatizing the certification business in order to move at the speed of industry. 100% of the certifications are performed by private sector at this time. And here's a typical grant of authorization. It shows that who's the grantee, what the device is, what frequency range, what power levels. All of those are on there along with the grant notes that tell you how you can and cannot use that device. Shows rule parts. What rule part are you done? FCCB. This one here shows just a digital device or a computer peripheral. And the grant note says all electrical and mechanical devices employed, etc. So it tells you how and when you can use that device. So if you wanted to do a certification, you'd have to put in an FCC ID. Your FCC ID is an alphanumeric number that's unique to the products that you make. The first five letters now are the grantee code from the FCC. The FCC gives you that, and any device that you make for your company will have to have that grantee code associated with it. The rest of the numbers, 13 up to a max of 13, is from the manufacturer to help identify that device as a unique device. Once you have the FCC ID and you get certified, all of the information goes to the FCC database. And the FCC has a nice search function. If you know the FCC ID, you can search for that product, and you would get a screen such as this that shows the different certifications or permissive changes, things like that for that device. It'll tell you when it was granted, what the frequency is, what the frequency of use is, etc. Now, the regulations cover all of this information. When you go to Part 15, you do unlicensed low-power transmitters. As you see, there's a lot of other parts there, but general requirements, again, come from Part 2. And here's a list of some of the others. Satellite communications, telecom service, television, broadcasts, all have their own sections in the regulations, as well as these devices. Suppose you don't understand the regulations or you have a question. The FCC has a knowledge database system. The KDB system is there to inquire to the FCC to get their take on what the requirements are or answers to your questions. A lot of times the industry Canada accepts the guidance from the KDB requirements, but you really have to check with the FCC and see about using non-standard test methods, etc. TCBs now, if there's a new technology, they have a PC permit but ask. They have to get in touch with the FCC to show how they're going to test it or how they're going to certify it. If the guidance is clear, then the TCB can do the guidance. If the PBA is due to test procedures, you'll typically need to contact the FCC through the KDB systems, resolve all the testing issues before the testing begins. Submit your KDB communications with the FCC to the TCB at the time of certification so that they don't have to go back and look it up. Just send that information along with your certification package. Technical requirements, you can see a couple of devices here that are both licensed and unlicensed. Unlicensed versus licensed. Licensed devices are more regulated and are protected. The licensed device frequencies are protected. So you can't interfere with things like the weather radar, things like that. Unlicensed devices are unprotected. So the basis, usually in the ISM, the Industrial, Scientific, and Medical bands, 2.4 gigs, 13.56, etc. What do we have for unlicensed? Well, we have Wi-Fi, we have Bluetooth, cordless phones, remote control devices, UWB devices, spread spectrum, uni devices, and unlicensed are used. Again, the unlicensed use is unprotected. So if you're interfered with, it's not anything the FCC can do about that. Licensed devices include land mobile radios, cellular telephones, broadcast transmitters, business radio applications, radars, things that have to have that frequency in order to work all the time, so they are protected by the FCC. Part 2 of the rules covers the general regulations and then filling out and filing procedures which apply to other rule parts. About 15 different radio service rule parts which require equipment authorization. Technical standards for licensed equipment are found in various radio service rule parts, for example, Part 22, 24, 25, etc. Technical standards for unlicensed equipment are found in Part 15. Good place to find the up-to-date rules is at this URL, the transitions.fcc.gov OET info/rules. You can get the latest rules, which is always a good thing to look at when you're doing a project. Generally, there's unlicensed scopes A1 through A4 and licensed scopes B1 through B4. Permit but ask is where the TCB asks permission to grant the device. CFR 47 Part 2 1046 and 1055 test results for all the devices. Okay, so all devices have to have RF power out, modulation characteristics, occupied bandwidth, conducted spurious emissions, radiated spurious emissions, frequency stability. All of this has to be there unless the specific rule part doesn't call these out. For example, there's no limits for temperature stability, frequency stability in Part 15, so you wouldn't have to submit that. The Industry Canada, the RSS Gen, the RSS 102 for RF exposure, the RSS 210, 210 for license fees, and RSS 220 UWB. They have 40 some odd titles in all. All have to be looked at to make sure you're complying with all the right requirements. So we have to measure these devices. What measurement standards do we have? Well, we have the ANSI C63.4, the 2009 or the 2013 version. They're actually going to change that again to the later versions. And that's just measurements of radio noise and emissions from electronic equipment. ANSI C6310 2009 was a standard for testing unlicensed wireless devices. TIA 603D was land mobile FM or PM or pulse modulated communication systems. The FCC's rules, regulations, and special procedures. The FCC from time to time puts out actual procedures for DTS, uni, millimeter wave, etc. And this all can be found at the FCC's site. C6326 is in draft for licensed devices, should be out soon. In the year 2011, there was 4,412 grants for digital device or digital transmission systems. There was 2,514 spread spectrum devices and 1,761 low power communications devices, about 1/3 of the total authorizations. Let's look at the unlicensed requirements. They have to have a good design. It cannot be adjusted by the user. There's no adjustments that the end user can have on that device. Operators of Part 15 devices got to cease operations if they're interfering, and the operators must accept interference. There's a couple labeling devices. You put the FCC ID on a label. There's also the FCC logo for DOC devices. Systems can be assembled from certified devices. A label or statement shall be etched, engraved, stamped, indelibly printed, or permanently affixed to the device. Cannot be located on a removable part for like a battery cover. and we do allow for electronic labeling at this time. Application items, you got to have a series of cover letters, a request for confidentiality if you want it, test report from the laboratory, modifications performed during testing, user's manual, theories of operations, schematics, block diagrams, test setup photos, internal, external photos, FCC ID label artwork and position on the device, and attestation statements such as the conditions of the installation. All these items have to be collected for the application and apply the right, for Industry Canada, you have to apply the right standard as we discussed, collect all the technical documents required for certification and submit them to the certification body. Certification body reviews the applications, uploads all the documents to the IC and FCC websites, and CB's own certificate received from the CB. The IC certificate you'll get right from the CB, and it gets, the equipment gets listed on the radio equipment list in Canada. Mobile phone, cell phone providers are obligated to provide a certain amount of their products that have HAC, which is hearing aid compatibility. There's 2 or fewer models, they don't have to do it. If there's 3 or more, at least one of them has to have the hearing aid compatibility requirements addressed. Began in September of 2012 that the big guys must offer one. And that's under the new version of ANSI C63.19 for hearing aid compatibility. Intentional radiators in Part 15 covers a lot of the consumer devices that we have in our pocket today. Here's a list of the different rule parts. As you can see, they're quite extensive. There's RFID, remote controls, FM radios, Bluetooth, vehicle ID, vehicle radar, etc. UNII, unlicensed national information infrastructure devices, all is covered in Part 15.400. All UWB devices are in 15.500. 15.203 is a part that most devices have to comply with. An intentional radiator is designed to ensure that no antenna other than the furnished one can be used with the device. So it has to have a unique connector if it's a antenna that can be taken off. Permanently affixed is acceptable, so that they won't be able to take those away. Professional installation. The intent of what is modular approval? Well, modular approval is an approved radio device that's done as a module. These products are great for Kickstarters because you don't have to address the radio portion of the device. You just have to install it the way they said and make sure your device complies with the digital requirements, because all the radio portion has been taken care of with the modular approval. If you have received your FCC grant and you're ready to start shipping, if you received your IC grant, you got to wait a little bit because you got to wait for it to appear on the IC website before you can sell your product in Canada. And I want to kick it back to Mike for a couple regulatory overviews, and we'll go from there.
Okay, Steve, in the time remaining, we'll try to cover the rest of the world here. Particularly, we're looking at some of the interest in Japan. There's been what's called a U.S.-Japan Mutual Recognition Agreement was signed a few years ago, and so now there's access to the Japanese certification market that you can take advantage of here in the United States. Similar to the Europe and U.S., the radio approvals are mandatory. There are several different classes of equipment that are covered by the Japan radio law, so-called, and that includes licensed and unlicensed devices. Now, it's kind of interesting is that there is one class of device that is exempt completely, and this is license-free devices, but they have to have very low power, basically below the Class B limits. So the Japan radio law is the driving factor for Japan certification, and the procedure is similar to Part 2 of the FCC, if you're familiar with that. So this law, number 131, covers the general requirements and also the structure of the rest of the law. The technical requirements are found in the ordinances, and the TELEC group is the original certification body that has promulgated some of the technical requirements, and if you're looking for your requirements for a specific device, you can reference the TELEC website. The core review items that come up here are very similar to any other kind of regulatory requirement. It includes the transmitter performance characteristics, information about the device, manufacturer name, model name, information on the performance of the antenna or antennas, and then anything that is based with the associated or ancillary equipment. Let's say you have a device that's a part of a medical product. You need to have a description of how the radio interfaces with that host device. And of course, we need to review drawing system diagrams, frequencies, and so forth. This is just a snapshot from a database that we take advantage of that looks at all the technical requirements, and particularly around the 2.4 gigahertz range, which is a very popular frequency range for Wi-Fi. Pretty much the IEEE 802.11 limits and protocols apply here, but they're cast in somewhat a slightly different way for Japan. This particular curve, I show here the very low power transmitters where you are no licenses requirement, no certification is required. And so you can operate over quite a wide range of frequencies up to 10 gigahertz as long as your transmitter field strength falls below this curve here. And you can see in the mid-band from 30 megahertz up to, I guess that's 1 gig or so, you're essentially looking at the below the Class B limit for unintentional emitters. So this is very low power stuff, but it may be useful in some certain short range types of devices. There is something called Modular Approval, independent of host, similar requirements to the FCC. So if you are integrating a module that already has approval, Japan approval, this basically allows you to do this without any additional certification. The requirements for an application are similar to the requirements for FCC. There is a requirement for a quality system, however, is one unique thing for Japan. And there's also requirements that the device cannot be tampered with or adjusted. The rest of the information that's applied with the certification includes photographs, labels, operational descriptions. Many of these same kinds of applications can be done in multiple countries. So a device that is getting certified for North America, you can use much of the same information for other approvals. This is what the label look like. You must have these elements where R is for radio, XXX is the foreign certification body that issued the certificate, and ABCDEF is a serial number that is applied by the certification body. And here's an example of a certificate. It shows the device name, the company name, the location, the frequency range, the emission designation, which is a characteristic of the modulation that you may use in the radio product, as well as the output power. In Japan, there are EMC requirements, general EMC requirements, even for non-transmitters, and this is a voluntary regimen under the Voluntary Control Council on Interference. This is usually you need to be a member of VCCI, and the laboratory that tests the device has to be a member of VCCI and approved on their list. This is primarily a market-driven sort of a mark. If you're looking at a consumer device with a large distribution, you may consider getting the VCCI mark, but it is voluntary. There are safety requirements, and there's a website here that you can look and find out if your device is on the regulated list. Across the China Sea here, we'll take a few minutes in the remaining time to talk about the China approvals. China safety approvals depend on the type and category of equipment. If your device falls on the regulated list, you have to get what's called a China Compulsory Certification Mark, or CCC Mark. And you must test in a national laboratory that has been recognized by the China authorities. Radio transmitters are regulated also. You must, and in this way you have to get what's called the SRMC mark. And this is also tested in an approved laboratory, again, in China. So there's been a lot of work to try to harmonize the requirements and work by the Department of Commerce and U.S. trade rep to create mutual recognition arrangements that will allow test data to be taken in non-China government laboratories or China designated laboratories, but some of these efforts have taken a long time. What do you need to get a CCC mark? Well, the usual bits, samples, instructions, applications form, of course, fees. In the Australia New Zealand area, there's they have pretty much had harmonized requirements between Australia and New Zealand for many years. What is recent is what's called the Regulatory Compliance Mark, which is replacing the old CTIC mark. This RCM mark will cover all EMC and safety requirements. And as far as applicability for electrical safety, it depends on a category. So you need to, again, look at the list of regulated products to see if you're on the RCM list. ACMA covers the radio equipment, and ultimately the ATIC will be replaced by the RCM mark. This is currently in transition, as I understand. The documentation you need to have on hand in Australia and New Zealand include a DOC, Declaration of Conformity, a compliance folder, which is a similar technical file, and you need to register, and you should nominate a supplier. So that is a quick round-the-world look at many different compliance requirements. For Kickstarters, things you have to also think about are medical device approvals. Are you handling food? Are you developing a toy? In the U.S. and abroad, there's also energy efficiency things that you may need to look at as voluntary requirements, but may help your marketing efforts. So in summary, success strategies for launching a product, you have to look at your device and define the largest market where equivalent technical standards apply. You would want to use IEC standards or equivalents in many cases. If you're integrating something, you should use pre-approved components and make sure that you verify the source and validity of their certifications. So check those sources carefully. And to the way you can do this, leverage approvals using something called the CV scheme. So Belinda, I think that's it for our prepared presentation. Should we go in a Q&A session?
Great. Thanks so much, Mike and Steve. We actually ran a little bit over, so we did run out of time for Q&A, but if anybody does have questions, you can definitely email us at info@interferencetechnology.com. We'll try to address them in the future. Please join us for EMC Live 2015, a 3-day event. It takes place April 28th to 30th, 2015. Webinar attendees, if you have any more questions we didn't answer here, please send us an email. A recording of this webinar will be available on our website. We also will send a link to all participants shortly. Thank you for attending.